Okay, so we're going to have a go at exercise 2a, question 15. Okay, so we've been asked to prove that for all elements AB in this group with set G and the binary operation star defined on set G, we've been asked to prove for all elements in this group, all elements AB that belong to set G, we want to prove that the inverse of the inverse of A is equal to A. Okay, so this notation here, star, just means binary operation, but just for the purposes of making it easy for myself, I'm just going to say multiply. Obviously I don't mean multiply, it could be add, it could be subtract, could be whatever, it could be whatever binary operation you like, but I'm just going to say multiply just to make it a bit easier on the tongue. So what I'm going to do now is I'm going to, okay, so what I can say is I can say the inverse of the inverse of A equals to Y, and then this means I want to prove that Y equals A. If I prove that Y equals A, my proof is complete, okay? So what I can do now is I can multiply the inverse of the inverse of A by the inverse of A, okay? What I would do to one side, do to the other side, so I'll multiply Y as well by the inverse of A as well, okay? So I know that an element multiplied by its inverse will just generate the identity element here, E, okay? So E equals Y inverse A, and now what I can do is I can simply times by A on both sides, okay? So I get E times by A is equal to Y times by inverse of A times by A, okay? So initially I had Y times by the inverse of A, but since I know that this is a group, I know that the property of associativity holds, so I can say this is exactly the same as multiplying these two elements first and then multiplying by Y. And obviously inverse of A times by A is simply the identity element, and anything times by the identity element is you just get the element itself, okay? So E times A is A and Y times E is Y. Okay, so here I have my proof is complete. I've shown that A equals Y, hence the left hand side of this equation here is equal to the right hand side, okay? Okay, so we'll have a look at the next question. So we've got part B now, is the same group, set G, with the binary operation star defined on that set. So this forms a group under that binary operation, and we want to show for every element A times B inversed is equal to the inverse of B times by the inverse of A. So this is quite a common proof. I've seen this in a few questions in a couple different textbooks. So again, what I'm going to do, I can say that A times B inverse is equal to Y. Okay, and the reason I'm doing this is that it might be a little bit difficult if I start to, so if I started from this stage here and I just started moving terms around, multiplying by inverses, etc., it's difficult to interpret what the answer is. Okay, so it makes it a little bit easier now. I've equated the left hand side to Y, and in order to complete my proof, I need to show that Y is equal to the inverse of B times by the inverse of A. Okay, so I need to show that Y is equal to the right hand side essentially. Okay, so same kind of process again. I have an element here. This is an inverse. I'm going to multiply by the element itself. So I'm going to multiply both sides by A times B. Okay, here I have an element multiplied by its inverse. We know that's the identity element. And obviously here I have Y times by A times by B. Obviously this is a group, okay, so I know that associativity holds, so I can say this is exactly the same as Y times by A times by B afterwards, okay? So now what I can do is I can just multiply both sides by the inverse of B. So I get E multiplied by inverse of B is equal to Y multiplied by A multiplied by B multiplied by the inverse of B. And obviously the inverse of B times by B is simply the identity element, and the identity element times by this is just going to be this. Okay, same thing goes for here. So I have the identity element times by inverse of B, it's just inverse of B, I get y times a on this side. Yeah, and I'm just going to times both sides now by the inverse of a. So I have b inverse times by a inverse is equal to y times by a inverse. Okay, so of course I know this holds here because of the associativity property. Okay, so I can multiply elements in any order I like. Okay, because this is a group, and therefore associativity must hold. Okay, and a multiplied by a inverse is simply e, and e times y is just y. Okay, so I have that inverse of b times by inverse of a is equal to y, and I've showed what I needed to show. So my proof is complete at this point. Okay, so there, those two questions, and I hope that helped.